guys, these are our notes about logarithm properties, or you might hear it like expanding and condensing logarithms. So these are going to go, these notes on slide 8 and 9 of your new digital notebook. At the top of your paper, you guys can go ahead and put your title, notes, logarithm properties. We're going to start by expanding logarithms. So there's three little rules that we're going to use to expand and condense logarithms. So first we have the product rule. The product rule says that if you have log base b and you're multiplying two things together, the way that you expand it is you see how there's two different things being multiplied here. There's an x and there's a y. So what you're going to do is however many pieces you're multiplying, you're now going to break it up into that many log base b's. So we have log base b, we need two of them, one for x and one for y. If these two things are being multiplied, then you put a plus sign in between. So let's do an example of this. So our example says log base 2 of 5ab. Okay, so we're going to do this example, log base 2 of 5ab. So notice how there's three things being multiplied here. There's 5 times a times b. So what we're going to need is three different log base 2's. We need a log base 2 for the 5, a log base 2 for the a, and a log base 2 for the b. Since all three of those things are being multiplied right here, we're going to go ahead and put plus signs between all of those things. So plus, plus. That's our expansion. All right, now we have the quotient rule. So the quotient rule says that if two things are being divided, log base b of x divided by y. So see how there's two things that are being divided, an x and a y. Each of those is going to get their own log base b for x, log base b for y. But instead of putting a plus sign in between, if you're dividing, that means you're going to put a minus sign in between. So the minus sign goes in between. If they are dividing, you subtract. If they're being multiplied, you add. So let's do an example of this. So our example says log base 4 of 3 divided by b. Okay. So there's two things being divided, 3 divided by b. So we're going to go ahead and need two log base 4's. Okay, they both keep the same log base 4 for the 3, log base 4 for the b. And then since these were being divided, you're just going to put a subtraction sign in between. All right, one more little rule for expanding and condensing. This next rule is the power rule. The power rule says that if you have an exponent, so log base b of x to the power of y, so this time the y is an exponent, when you expand this, the y actually gets written in front. It's y times, we just don't write it, but it's y log base b of x. So if there's ever an exponent, it gets written into the front. So let's do an example of this. So our example is natural log of a to the power of 5. So natural log of a to the power of 5. So since there's an exponent, we're basically just going to move that exponent to the front. And it's just going to be 5 natural log of a. And these are being multiplied, but you don't actually write the multiplication. All right, let's do an expanding example. So this is what like your homework problems are going to look like. It says expanding example. Log of x divided by 2 divided by, log x to the power of 2 divided by 5y to the power of 7. All right, so let's see how many pieces there are, and so we can decide how many logs we're going to need. So we have an x, we have a 5, and we have a y. Okay, so we have three bases, so we're going to need 3 logs. These are just regular logs. There's common logs. There's no base, so it's log base 10. So we're going to need 1 log for the x, 1 log for the 5, and 1 log for the y. So notice how I didn't put x squared is because our exponents get moved to the front. So it's going to be 2 log x. The 5 doesn't have an exponent, so nothing goes in front of it. The y does have a 7 though, so that's going to go in the front. Now notice how both the 5 and the 7y were in the denominator. That was a dividing problem, right? So since both the 5 and the y were in the denominator, they're going to both have a minus sign in between. The only one that's on the top is going to have a plus. That's the only one. The two pieces that are on the bottom are both going to have a minus sign. And that's our expansion. So this is expanding polynomials, or I'm sorry, expanding logarithms. We have 3 rules: the product rule, the quotient rule, and the power rule. So your homework problems tonight are going to look like this, where you have multiple letters, and when you expand them, you need 1 log for each variable or coefficient, and then when you go to have an exponent, you just write it in the front. If they're in the denominator, they get a minus sign in front. If they're in the numerator, they get a plus sign. Okay, so this is going to be the first picture that you put into your digital notebook on slide 8. Now we're going to talk about condensing logarithms. So go ahead and flip your paper over, and we're going to talk about condensing logarithms. And this is going to be, or these are going to be the same exact rules, just going backwards. Instead of expanding, making it bigger, we're going to condense and bring them into just 1 log. All right, so our product rule then, going backwards, if you have the same log bases, so log base b of x plus log base b of y, then when you when you condense them, you keep the same log base. They have to have the same log base to be able to do this, or else you can't combine them. All you have to do is multiply their 2 pieces. The product rule, you multiply the 2 x and y. So this is the same rule we looked at, and we went this direction. Now we're going the opposite direction to condense. So if you write down your example, log base 2 of 3x plus log base 2 of 5x. So for this problem, we're going to notice they have the same log base 2. That means we can condense them into 1 log base 2. And then what you're going to do is you have a 3x and a 5x. So in order to condense them, you multiply those 2 things together. So 3x times 5x, well, 3 times 5 is 15. X times x is x squared. So we multiplied them together. We got log base 2 of 15x squared. All right, let's look at the quotient rule. So the quotient rule we already used before, but if you have 2 pieces we're trying to condense, they have to have the same log base. If they have a minus sign in between, okay, if they have a minus sign in between, when you condense down to just 1 log base, they have to have the same base, log base b. When you condense it, when it has a minus sign in between, you divide. The one that was positive goes on top. The one that was negative goes on the bottom. So it'd be log base b of x over y. So let's try an example of this. So our example says log base 4 of 3x minus log base 4 of 5. So notice they have the same log base. So that's what we need, the same log base. So we condense it down to 1 log base 4. And then since it's a minus sign, that means we're going to make a fraction. The first one was positive, the 3x goes on top. The minus, the 5, that one goes on the bottom. So these pieces right here are what gets divided since it had a minus sign. All right, one last rule of, it's the same rule we had before, the power rule. So the power rule says that if you have something being multiplied in front of your log base, okay, whatever your original log base was, the way that you condense is you move this as an exponent. So you take that number that was once in the front, and it now becomes an exponent on your log piece. So let's look at an example of this. So our example says log base 3 times log base 7 of b. 3 log base 7 of b. So when I condense this, the number that was in the front now just becomes an exponent. Log base 7 of b to the power of 3. Okay? All right, so now let's do a condensing example. So we have a condensing example down here. It says 2 log base 3 of 3 minus 5 log base 3 of a plus 4 log base 3 of b. All right, so notice they all have the same log base 3, log base 3, log base 3. That means we can condense all of this down to just be 1 log base 3. Okay, there was originally three log base 3s, and we're going to be able to condense it all down to just one log base 3. Okay. All right, so notice how there's a minus sign. A minus sign means that you're going to have a fraction. This is the only piece that's going to go on the bottom. These two pieces are both positive, so both of those pieces are going to go on the top. Okay, so the piece that is negative is the only piece that's going to go on the bottom. So notice how it had a 5 in front of it. That 5, sorry, I'm going to kind of get rid of what I had there so you guys can see. But it means we're going to have a fraction because there's a minus. This 5 is going to be moved as an exponent. So this is going to be a to the power of 5 on the bottom. And then these two pieces, like I said, are going to be in the numerator on the top because they both are positive. And then if they have a number in front, you're going to make that an exponent. So this one's going to be 3 squared, which honestly you'd probably write that as 9. 3 squared is just 9. And then the 4 gets written as an exponent, so that'd be b to the power of 4. So we condensed it, it had a 3, an a, and a b. So we still have that 3, but I squared it, and then we have an a and a b. So again, if it has a minus sign in front, okay, if you see a minus sign in front, that means that that piece is going to go to the denominator. The number in front becomes your exponent, so becomes a to the power of 5, that's in the denominator. My 4 goes on the b, that's my b to the power of 4. That one was positive in front of it, so that's why it is in the numerator. This one was also positive. When I put the 2 on the 3, 3 squared became 9. And that's my condensed problem. That's what you guys will see on your homework tonight using these 3 rules. So these notes need to go on slide number 8 and slide number 9, and then the homework practice problems is on Delta Math.